Hello, a very good evening to all of you. So today we are going to discuss about NumPy, and this is the first tutorial of NumPy. So we are going to discuss some of the top topics first. So I have already written what are those topics that we are going to discuss today. So let me start. Okay. So okay. First thing I will briefly describe what is NumPy and why are we using NumPy. Okay, so um, let me write it. Um, NumPy is a numerical Python library. Um, it helps us to do numerical calculations in a much faster way than um, in a much faster way than it can be happened uh, in pure Python. Okay, so this is the small introduction about NumPy. So basically it is a Python library, and with the help of this library we can perform lot of numerical calculations and I am specifically making this tutorial on NumPy for machine learning purpose or for data science purpose. So let's start with this much introduction. So okay, so first thing is creation of arrays. Okay, so one of the most core component in the NumPy is ND array. So if you have already know about the Python or some programming language, then you must know about what are arrays, right? So what are arrays? You can say list in Python language. So for example, ARR in Python, how we write arrays or list. There are like 15. Let's say I am creating a numerical array of some numbers, so 15, 50, and then 60. I am only using three numbers. Okay, so if I want to print, and I will simply write ARR, so it will comes out to 15, 50, 60. I can iterate over the list, and so I can print the individual entry one by one. For example, like this: for I in ARR, print I. So this will give me the entries one by one. So well, this is good, but we are here to learn about NumPy. So I have told you that one of the core component in NumPy is ND array, and let me show you what it is. So ARR, once again I am defining an array with the help of NumPy. So before using the NumPy array, we have to import it first. Okay, so how can we import the NumPy array? Okay, so I am writing here importing NumPy. Importing NumPy. So import NumPy as np. So first you have to install this. Okay, so I think that you know how to install NumPy. If not, you can simply open your terminal. For example, I am trying to open my terminal. Okay, so I can open my terminal from here. You can open your terminal if you are working in Windows. Then also you can open command prompt or PowerShell, or if you are in Ubuntu or some other Linux distribution, then also you can open terminal. And what you have to write first, you have to write pip install NumPy. I think so this is correct. Yeah, This is correct. So it is saying that requirement already satisfied. It means I have already installed Numpy. Okay, so I don't need to install it again. Okay, so now I have imported the Numpy here as np. Okay, so we are going to use the np as the alias name for numpy. So now how we are going to create an array from list. Okay, so creating create numpy array from list. Okay, so let us create a numpy array. Okay, so name it arr1. Then it will be it will be created as np dot array, and inside this you have to pass a list. Okay, so you can pass a list in any way. You can explicitly define the list here, for example 12 comma 13 comma 15. And okay, so in this way also, if you want to print, you can print like this. Okay, print ar1. So yeah, 12 13 15. Okay, or you could have the same elements from the above list like 15 15 15 or 60 and 16. So okay, so if so okay, and you can also create numpy array like this if you want to. Np dot array, and inside array what you have to pass, just a list. So I can simply pass the name of the list or the reference variable that is pointing to list like this. Okay, so I have not printed it. Okay, so let me print it. Print arr2. Now it's fine. Okay, so both are same. Okay, so if you want to check if both are same or not, you can simply write like this. So arr1 equals to arr2. I think it should give you true. So okay, so basically it gives me array na. So what you other thing you can do is arr1 is arr2. Okay, so is operator checks the address, right? So the answer is false. So basically they both the objects are not same, they are different. Okay, it's fine. In memory they are different. Okay, it's fine, but the content wise they are same. Okay, so we have seen it before. If I want to print arr1 is arr2, that is we are comparing the address of both the numpy arrays, but here arr1 is equals to arr2. Here we are comparing the contents. Okay, fine. Okay, so the question arises, what is the use of these np dot array? Okay, I mean, what is the use of using numpy? We are having the same output. See here, it is the same list and it is also the same list. So what is the difference? Basically in numpy array, there is a difference of efficiency and run time, or you can say execution time. In list I can use a heterogeneous object. For example, I can use a string dev. Okay, but here I cannot use the string dev. Okay, let's see. Yeah, so here 15 50 60 dev, but here it is only here also 15 50 60 dev. But if I try to store dev string here, I think I can, but there will be I mean these number will also be converted into string. Okay, so numpy arrays are homogeneous in nature. They cannot contain heterogeneous objects. So whereas list can contain heterogeneous object. Okay, so there is a lot of difference between a Python list and a numpy array. Okay, but for now just understand this, that numpy array are much more efficient and faster than normal python list. Okay, so we have seen how to create an array from list. Okay, so let me also tell you how to create a list, I mean how to create a numpy array from a tuple. Okay, so same way, create numpy array from tuple. So what we are going to do, arr3 is equals to np dot array, and inside this we are going to pass the tuple. Okay, so 2 comma 3 comma 5, and we are going to print it. Okay, so okay, there one parenthesis left, so fine, arr3. Okay, so it come out to be array 235. Fine, so we have now seen how to create arrays from list and tuple. We can also create two-dimensional or three-dimensional or as many dimensional array we want. I have just shown one dimensional array. Let me give you an example of two-dimensional array. Okay, so okay, fine, arr, let's say 2d. So how am I going to define it? Np dot array, and here we are going to use two brackets. Okay, so one bracket for the main dimension, I mean the principal dimension, or you can say um, what is basically two-dimensional array. It is the array consists of arrays, right? So for example, 1 comma 2 comma 3, and then 4 comma 5 comma 6, and then 7 comma 8 comma 9. Okay, so it may seem like a matrix, that is 3 by 3 matrix if you have studied math, and I presumably assume that you must have studied math before coming to this tutorial. Okay, so let me just define it as b. Okay, so basically I will use this to demonstrate other examples. Okay, fine. Okay, what happened here? Okay, so let me just print it. Actually this is the Python, so basically a Jupyter notebook, so I don't have to write the print b, because the last line will get evaluated. Okay, if I write print b, then the value of b will be printed. If I don't write print b, if I only write b, then also the value will be printed. Okay, okay, fine. So yeah, so in this way we can also define two-dimensional arrays in numpy. Okay, so now let's see how can we create arrays from several functions, or you can say how can we create specific types of arrays. Okay, so okay, so first thing, from zeros. Okay, zeros. So let me do this. Okay, so how can we create it? It is simple. So np dot, I'm not assigning any variable because I don't need to store. Okay, I'm just showing you how can you I mean how can you define the array. I mean what is the function of this I mean what is the functionality of this function zeros. Okay, so here e will not be there. Okay, zeros, I think so. np dot z zeros. So for example, if I write 5 here, okay, so what will happen? Okay, let me assign the variable so that you can understood easily. Okay, so if I print a, it will give me one dimensional array in which there are 5 zeros. Okay, so I think you can now understand what it exactly does. Okay, so I will write it here. It creates an array with 5 zeros. Okay, fine. So let me create another array, let's say a1. So what I am going to create now a two-dimensional array. Okay, so how am I going to create a two-dimensional array? It is very simple. So you just have to write np dot z zeros, and then inside this you have to pass a tuple of some dimension. Okay, so for example, I want to create a two-dimensional array of in which all the elements are zeros. Then what will I do? For example, if I want to make a matrix or make a array that is 3 by 3 dimension, or let's say 3 by 4 dimension, then I will simply write it as 3 comma 4. It means 3 rows and 4 columns, right? Okay, so let me just print it. Okay, you can see now it have 3 rows. I mean the horizontal horizontal lines are rows. So first row, second row, and third row, and I mean 4 vertical columns. Okay, fine. So I think now you have understood how can we use zeros. Okay, so np dot zeros will create a array that consists only the zero element. So let's look on ones, because we sometimes need a array that is completely filled with one. Okay, so let's see. Okay, so let me just write the heading ones, and then what we are going to do, let's say a is equals to np dot ones. It is simple. Now same, if I write it 10, then you can anticipate that what is going to what is going to print. Okay, so I think you have I mean you know what is going to be printed. So it is a one-dimensional array consist of 10 ones. Okay, it is very simple. If I want to create a two-dimensional, or let's say three-dimensional array which is consist of ones, then you can simply write let's say a1 is equals to np dot ones, and inside it you have to pass a tuple. So for example 3 comma 4 comma 5. Okay, no, not 5, let's say 2. So okay, so first I should show you two-dimensional array rather than three-dimensional array. Okay, fine. Okay, so I have to print it, right? Okay, a1. Yeah, so same structure with the previous one, 3 rows and 4 columns, right? Okay, so let me show you also the three-dimensional array here in this case. So np dot ones, same, we need to insert a tuple inside it. So how are we going to insert? So simply 3 comma 4 comma 2. Okay, so 3 comma 4 comma 2, I mean. Okay, so see here, a2. Yeah, so it basically mean 3 two-dimensional arrays and 4 one-dimensional arrays, and scalars are 2, just 2. Yeah, it follows what I have written inside that tuple. I think that it can be little bit difficult to understand what I have written here. If you don't understand, don't worry. When we will see shape, I will make you understand a little bit better. Okay, I will try to make you understand better than now. Okay, for now I should remove this. Okay, I think so. Fine. So np dot ones 10, and then np dot ones 3 comma 4. Okay, so we have seen this function, that is zeros, and we have seen ones, and now we should see. Okay, so here comes the question. If I want an array which is uniformly filled with zero, I mean we can use zeros function. If I want a array which is completely filled with ones, then I can use np dot ones. But what if I want an array which is filled with 5 or 10 or maybe 100 or any number we want? So for that there is a function known as full. Okay, so I'm writing here full. So how can we create it? It is as simple as we have done the above two. So np dot full, what we have to do, we have to just pass the size of the array. If it is one dimensional, then we just have to pass the one digit, for example 10, and then separated by a comma, and then we have to write which digit we want to fill our array with. So for example, I want to fill my array with the digit 7. Okay, so if I want to print, okay, so I think it is going to print. Yeah, it is correct. It is one dimensional array filled with 7. Okay, and how many digits are there? 10. Okay, so because we have specified 10 there. Okay, so if we want to create a 2-dimensional or 3-dimensional or multi-dimensional array with a specified digit, then we can use full. Okay, let's see how we can use full. A1 is equals to np dot full, and then this bracket. Okay, so let me just, okay, so we have to pass the tuple in place of scalar. Okay, so let's say 3 comma 4, and here we have to pass the digit by which we want to fill our array. Okay, so let's say 3, so a1. Okay, fine, it is 333. Okay, it's fine. Now we have seen how to create arrays from 3 different functions, that is zeros, that is ones, and that is full. And we have seen 2 primary ways to create array, and that is from list and tuple. Okay, so we have seen 5 ways. Okay, let's see some more common sorry. So let's see some more common ways to create arrays, I mean numpy arrays. Okay, so another way that we can create array. Okay, so let me ask you a question. So why we are discussing these functions, I mean ones, full, zeros? Because they are very common. Okay, we sometimes need an array, that is, we sometimes need an array filled with only zeros, and we sometimes need an array that is filled with only ones, and we also need sometimes array that's filled with some single scalar quantity. Okay, you will see, you will definitely see in when you will do further studies. Okay, so another thing is that if you are from, okay, so sorry for the background noise and all my stuttering. I hope you will not mind it. Okay, fine. So okay, so I want to ask you a question. For example, okay, so dogs are barking a lot. Okay, fine. Okay, so yeah, I want to ask you a question, that if you want to create an array that consists a range of numbers, right? Then what will you do? You can simply use the function arrange. Isn't it funny? arrange or arrange, it doesn't matter, we are just going to use it. So a is equals to np dot arrange, and inside arrange, if you have studied python, which I think that you must have, then you must know the range function, right? So what does the range function do, can you tell me? So range function basically take a start index or start value, and then we take range take a value that is the stop index, and then it take a step. Okay, so um, that the stop is exclusive and start is inclusive, and step is how much step we want to jump, like arithmetic progression. Okay, so so in the same way arrange function works. For example, if I want to generate 1 to 10 numbers, okay, if I want to generate a one dimensional array that consists of numbers from 1 to 10, then what will I do? 1 comma 11, because 11 is exclusive. If I write 10, then it will only print 9 numbers. Okay, I mean 1 to 9, that is why we have to write, yeah, you can see here 9, there is no 10 because the stop index is exclusive. I mean it does not go till the last index, it will go -1. Okay, till -1. So we have to write it here 11, so it will go from 1 to 10. And after, and you can also specify the step, the default step is 1, and you can specify whatever, how much jump you want to do. For example, if I want to do jump by 3 step, then I think I will get 1 4 7 10. Okay, it's completely fine. Okay, so you may ask that can we create a two-dimensional array from arrange? Well, we can, but with the help of some other methods that we will see later on. Okay, but for now we can only create one-dimensional array from arrange. Okay, so there is another important method, that is the I. And what does I do? Okay, let me tell you. So I think you have must know you must know about the identity matrix, I think so. So identity matrix in mathematics or linear algebra. Okay, so this I function is used to generate that identity matrix. Okay, so extremely sorry for the noise from my side. Okay, fine. So a is equals to np dot I, and we can simply pass, I think, one argument. I don't think it will work. Yeah, it works. Okay, let me see what is the output. Yeah, it works because identity matrix is n cross n. So yeah, n cross n, so it will generate n cross n matrix. So I have passed 3, so it will generate a 3 by 3 matrix. Okay, so now what okay, so let me check. I have not seen this 3 comma 3, will it work? Oh, it will not work. Fine, it will not work. Okay, fine. So we only have to pass an integer. Okay, because it is n cross n na, isliye I mean that's why. For example 5, then it will create an identity matrix of 5, I mean of order 5. Okay, so we have seen a lot of functions to create matrix, I mean numpy arrays. Okay, so is there anyone left? Okay, so linear space and uniform distribution, normal distribution. Okay, fine. So sometimes and I think it is one of the most important function if you want to draw graphs. Okay, so we want several numbers between some range. At that time we have to at that time we will use a function known as linspace. Okay, okay, fine. So let me show you how it works. For example, if I am defining a numpy array, that is a, which is equals to np dot linspace and np dot linspace. Okay, so first we have to define in what range. Okay, for example, I want to define 1 to 10. Okay, I want values between 1 to 10. How many values do I want? Do I want 10 values, 20 values, 50 values? Let's say I want for now 20 values, and these values will be evenly spaced. Okay, so there will be, I mean, for example, you take a arithmetic progression. Yeah, it is like arithmetic progression which have the common difference same. So here also, so let me just, okay, fine. Yeah, so 1, then 1.375, then 1.75, then 2.215. Also let me just reduce the number of elements to 5, so that it can I think you can better visualize it. Okay, so first number is 1, second number is 2.2, I mean 3.25, and then 5.5, and then 7.75, and then 10. Okay, so how it works, it is something like this. I am writing it here, linspace, and then you have the starting range. No, not a starting range, what should I say, start of the range, like this. Then you have the end of the range, both are inclusive. Okay, and then you have the number of number of values. Yeah, okay, fine. Okay, do you understand it? So if you ask me, can we only create one dimensional array for the time being, or as this is the first session, and we don't know, I mean, you don't know about some specific attributes or functions, so we will say, yeah, we can only create one dimensional array from linspace. But yeah, we can convert this one dimensional array in two dimensional, or whatever the dimension we want, it doesn't matter. Okay, but for now, yeah, we can only create one dimensional array. Okay, so one thing I want to say, that I am recording these sessions um, just for my revision purpose. Okay, so if any content is wrong, okay, I will try that no content is wrong, because it is programming. So whatever I will say, most of the thing will be proved in front of you, as it is programmed. So yeah, but there can be issues. Okay, but I will try to be more accurate. Okay, fine. So let's go to another. Okay, so uniform distribution and normal distribution. Okay, okay, so there is a function to generate values that are uniformly distributed. Okay, basically random values. Okay, so how can we generate random values between two integers? For example, you all have played Ludo game, right? Ludo game. So in Ludo game, we always get numbers from 1 to 6. Okay, so sometimes we get 1, sometimes we get 2, or any number between 1 to 6. So if I want to generate a number between 1 to 6, so I have to use another function. Okay, so that is the different context. Okay, so what I am going to discuss here is, I want to generate different numbers between some range, and the actual range here will be between 0 to 1. So let's see the function. So that function is known as rand. Okay, so np dot random dot rand, I think so. Let's see. So a is equals to np dot random. I think it comes under the random module rand, and inside this we have to pass the if we pass scalar, then it will generate one dimensional array of that much length. For example, if I pass 10, it will only pass one dimensional array of length 10. Okay, see. Okay, so I have not why. Okay, fine. Yeah, okay, so it is not between 0 and 1. No, it is just at a, yeah, it is between 0 and 1. If you are able to see, you can see, and if not, no worry, because what I can do, fine, I can just simply write like this. Don't try to understand it right now. 0.3f, let's say 3f. Okay, yeah, now it's correct. Okay, string formatting, unseparate formatting passed through Numpy format. Okay, so it can't be formatted like this. Okay, fine, so just leave it. So yeah, just believe me, they are between 0 and 1. Yeah, you can see now they are between 0 and 1, and it is one dimensional array. It is not the two dimensional array. Don't be confused with the representation here. Okay, so let me just do this. Yeah, so these values are uniformly distributed. If I draw the graph of these values, then you can see that they are uniformly distributed. Okay, fine. So if I want values that are normally distributed, what I can write rand n. Okay, so let me just show you. A is equals to, okay, so there comes a question that in rand function can we only generate one dimensional array? No, here you can generate multi-dimensional arrays also. For example, let's see, a1 is equals to np dot random dot rand, and then what you can do, you can simply pass a tuple. Okay, so for example 3 comma 4. Yeah, okay, tuple is not so we can't, I don't think so. I think we can. Okay, so let me do once again. 3 comma 4. Yeah, we can. It's just that yeah, we can. So we cannot pass with parenthesis. We can only pass like this. Okay, 3 comma 4. Yeah, so it have I mean it has 3 rows and 4 columns in it. Okay, fine. So the same scenario with the rand n function. The only difference is that these values are uniformly distributed. It will be much more clear if you if let me just show you. Okay, let me just try to show you. Okay, fine. So uniform distribution. Okay, so if I show you, uniform distribution is like this. So if you plot these points on the graph, you will get some curve like this. Okay, I mean it will not be like this. This curve is normally distributed. That this curve will be plotted by those values which will be given by rand n function. Okay, so let's just see this. A is equals to np dot random dot rand n, and you can just pass 10 to just to get a one dimensional array. Okay, yeah, so it starts at minus 3.5 and it goes to yeah, it goes to 3.5 definitely, because the first value is this and second value is this, not this. Okay, the values are little bit confused, but believe me, they are normally distributed. Okay, so now we are going to create a random array, I mean two-dimensional array, okay, here for normally distributed values. So np.random.randn, and inside it we will pass 3 comma 4 to generate and 3 by 4 array. So a1, okay, fine, yeah. So we have the 3 cross 4 matrix. Okay, so it is filled with normally distributed values. Okay, so we have done these functions. So any more function left? Linear space randint, yeah, randint, yeah, it is one of the most I mean, I like this function a lot, randint, because these decimal numbers I don't like that much. So because we humans have worked with integers from the starting, that is why I personally like integers. Okay, so randint. Okay, so what it does, it basically creates a random array, but of integers, not decimal numbers that are fixed and confined between 0 and 1. Okay, for example, a is equals to np dot random dot randint. Okay, so if I just pass 10 here, then it will simply give me 10 random integers. Okay, one dimensional array filled with 10 random integers. See, oh no, why is that? Because I think 10 here passes as the upper range, and so it will not, it will never give me number greater than 10. Okay, fine. So to specify the range, what you can do, you can first specify the range. For example, I want my number between 1 and 20, and how many numbers I want, let's say I want 10 numbers. Okay, so simple, right click like this. Okay, so 18 comma 6 comma 16 comma 17 comma 14 and so on. Okay, so now comes a question that can we only create one dimensional array? No, we can also create multi-dimensional array here also. For example, a1 is equals to np dot random dot randint, and then we first have to pass the range between what we want our numbers. Okay, for example, if I want to create a Ludo game, then I will definitely pass from 1 to 6. Okay, I only want my numbers between 1 and 6. After this we will pass a tuple. Okay, to create a multi-dimensional arrays. For example, if I want to create a 3 by 4 array, and I will simply create like this. Okay, so I have to print it right here, a1, yeah. So I just got integers between 1 and 6. Okay, so I don't know why, but I don't get 6 here. Okay, it's fine. Okay, so we have discussed these many functions, right? Yeah, so I think that we should stop here. I can uh, upload the next video, and in the next, okay, so one function is left. Okay, so empty. Okay, so empty function basically creates an array, and which will take the value of the array, which I mean the array which does not have any variable associated to it. For example, a is equals to np dot empty, and I think I don't have to pass anything. So yeah, no, I have to pass. So for example, 10, yeah. So it has just okay, it has just taken these values, yeah. because the reason is I have defined this array with the reference variable a, but this reference variable I have given to this array. So now this array doesn't have any reference variable. That is why the array which is compatible with its size and does not have any reference variable, it will comes to the empty. Okay, so it can take any arbitrary array. For example, if I pass the 3 comma 4, then I think it will take this array most probably. I think so. Let's check it. Okay, 4 cannot be as data type. Okay, fine. So I think I have to pass a tuple. I think so here 3 comma 4. Okay, yeah, I have to pass a tuple. So yeah, it has taken some array. Okay, fine. So the values are too much small, very much small. Okay, fine, no worry. But you just see that it prints the arbitrary array. We sometimes need an array which is not relevant to us, so we can use a empty. Okay, so now we have covered so many functions. We will see attributes and array indexing and array slicing and these accessing rows and columns in the next tutorial. Okay, I hope you gain some knowledge about Numpy from this tutorial. Okay, so I am recording this session in the night, so have a good night. Okay, we will meet soon or again.